Good morning to all of you. Myself, Professor N.V. Arpe from SNT College of Engineering and Research Center, Yeola, working as a assistant professor in Electrical Engineering Department. So, in previous lecture, we studied we already studied the long duration and short duration voltage variation. In uh, in that lecture, we will study the voltage imbalance. Voltage imbalance and waveform distortion. What is voltage imbalance? Voltage imbalance or voltage unbalance. This concept arises in three-phase system. It is useful to three-phase system. Voltage unbalance is defined as the maximum deviation from the average of the three-phase voltages or currents divided by the average of the three-phase voltages or currents expressed in percentage. That is the ratio of either the negative or zero sequence component to the positive sequence component can be used to specify the voltage unbalance. This will be depend on the fault, on the types of faults occur in the system. Due to that, the zero sequence, positive sequence, and negative sequence component are produced. The voltage unbalance can also be the result of blown fuses in one phase of a three-phase capacitor bank. Means due to this voltage imbalance, one any one phase fuse of the capacitor bank will be destroyed. If voltage imbalance of less than 2% is single phase loads on a three phase circuit, means in that condition there is a load unbalanced load on the three phase system. Voltage imbalance is greater than the 5% can be result from single phasing condition. Can result from single phasing condition. Means any one phase having the magnitude is change greater than 5%, then this will be occur from the single phasing condition. This is also your voltage imbalance in the system. Waveform distortion. Now, what is the waveform distortion? This is your purely sinusoidal waveform, and this is your distorted waveform. This is called as distorted waveform, and this is your pure waveform or sinusoidal waveform. The waveform distortion, it is defined as a steady state deviation from an ideal sine wave of power frequency, principally categorized by the spectral content of the deviation. Means some deviations or some changes is available in the waveform of the sine wave having power frequency. It is called as waveform distortion. This waveform distortion will occur due to the following phenomena, that is DC offset, harmonics, interharmonics, notching, and noise. The DC offset, the presence of a DC of voltage or current in an AC power system is termed as DC offset. This is called as DC offset. disturbance or asymmetry of electronic power converters and incandescent light bulb life extenders. These are the DC offset, and due to this DC voltage or DC current present in the AC system, due to that the voltage distortion will be occur. Second one is harmonics. Harmonics are sinusoidal voltages or current having frequencies that are integer multiple of the fundamental frequency. Due to that, the frequency will be the frequency of the supply system will be changes. So this is your pure sinusoidal waveform, and this is your distorted waveform. This will be occur due to the harmonics present in the system. The TH related total harmonic distortion, which will be find out by using the formula. The total harmonic distortion levels are described by the complete harmonic spectrum with magnitudes and phase angles of each individual harmonic component. Then total harmonic distortion in a voltage is equal to 100 into V2 square plus V3 square plus dash 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 up to Vn square upon V1%. It is called as your total harmonic distortion. That means the distortion produced in the waveform. This is also used for the current. Similar formula, only changes is voltage and current. The interharmonics, the voltages or current having frequency component that are not integer multiple of the supply frequency. The sources of interharmonic waveform distortions are static frequency converters, cycloconverters, induction furnaces, and arcing devices. Induction furnaces and arcing devices, and due to that, the voltage waveform distortion occur in the system. Next one is notching. Notching is a periodic voltage disturbance caused by the normal operation of power electronic devices when current is commutated from one phase to another. This will be notching. This is a periodically voltage disturbance. This is periodically voltage disturbance, and this will be causes by the operation of electronic devices. Causes by the operation of the electronics devices when current is commutated from one phase to another. Notching occurs continuously. It can be characterized through the harmonic spectrum of the affected voltage. The frequency components associated with the notching can be quite high and may not be rapidly characterized with measurement equipment normally and used for harmonic analysis. Next, this is your notching, and due to this notching means due to the operation of the power electronic devices, the notching will be occur. This is your notching time, and due to that, the voltage variation, waveform distortion will be occur. And the last topic is noise. Noise is defined as the unwanted electrical signal with broadband spectrum content lower than 200 kilohertz super, superimposed upon the power system voltage or current in phase conductors or found on neutral conductors or single lines. Noise in power systems can be caused by power electronic devices, control circuit, arcing equipment, loads with solid state rectifiers and switching power supplies. Noise disturbs electronic devices such as microcomputer and programmable controllers, and noise can be mitigated by using filters, isolation transformers, and line conditions. Next one is voltage fluctuation. Are the symmetrical variations of the voltage envelope or a series of random voltage changes, the magnitude of which does not normally exceed the voltage range from 0.9 to 1.1 per unit. Means the change in the voltage from 90% to 110% of the rated voltage, it is called as voltage fluctuation. So in that lecture, we studied the voltage unbalance and waveform distortion and voltage fluctuation. So thank you.